In this problem, we're told that we have a cart that started at the origin and then it moves according to this given velocity time graph. So if we look at this velocity time graph, again, the vertical units there will be meters per second. We can see that the car is moving at 5 meters per second for the first 5 seconds, and then it suddenly switches to moving in the negative direction, and it's moving negative 3 meters per second for 4 seconds. In part A, we want to get the total displacement of the car. And you can look at this geometrically. It's just the area bounded by the velocity time graph. And I have some positive area over here, this square that has a height of 5 and a width of 5. And then I have some negative area. Remember, the area under the t-axis counts as negative. And this is going to make sense because the cart is moving in the negative direction at that moment in time. So whatever displacement happens there should be negative displacement. So I start to calculate my area. And the height of this first chunk is 5 meters per second, and then the width is 5 seconds. I kept the units there to see that the seconds cancel out and I get meters as I should. Then the height of my other rectangle is negative 3. You have to keep that minus sign, indicating leftward motion, and that occurs for 4 seconds. So this gives me 25 meters minus 12 meters, which is 13 meters of total displacement. And we're done with that part. Now in part B, we're asked for the average velocity of the cart. Remember, the definition of average velocity is total displacement divided by how long it took. So we're just going to take that positive 13 meters, that was our total displacement for the process, and then divide by how much time it took to get there, which was a total of 9 seconds. And when we run the numbers on this to 3 significant digits, we get about 1.44 meters per second. Now remember, velocity is a vector, but here we're just using the positive answer, so the plus sign attached to this thing to indicate the direction of the cart. So we're done with part B. Now I do want to point out a really common mistake on part B is when students just take the arithmetic mean of all the different velocities they see in the velocity time graph. That is not going to give you the same answer that we got by using the actual definition of average velocity, total displacement divided by total time. So the common mistake here would be to take our velocity of 5 meters per second, our velocity of negative 3 meters per second, add those together and divide by 2. If you do that, you're not going to get the right number. Like this number, 1.44 meters per second, means that on average, the car covers 1.44 meters every time 1 second goes by. If you take the arithmetic mean, you actually get, let's just add these together real quick. So I added the two velocities, 5 plus negative 3, and then divide by 2. You actually get 1 meter per second for that. And that doesn't have any relevant physical meaning in this problem. So just wanted to point out that common mistake. What we really mean by average velocity is just total displacement divided by total time. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.